This will be a demonstration of a few of IBM's AIOps solutions, including Instana, as well as IBM Cloud Pak for AIOps, and how they can be used to remediate incidents that occur in a Linux on IBM Z or LinuxONE environment. So the sample application I'll be working with during this demo is called Acme Air. This is the topology of Acme Air, which we'll talk about in just a moment. Our demo application is it's a flight reservation system. You can log in as different users. You can search for flights from one city to another. You can check in for your flights, cancel those flight bookings if you like, update your account information, and do a couple different tasks. And whenever you interact with any of those microservices, and any one of those individual services is managed by a microservice running in OpenShift that is a Java WebSphere Liberty application. For example, for the customer service, the booking service, the auth service, and the flight service. Those are all Java microservices. And some of those Java microservices use MongoDB databases that are also containerized and running in OpenShift on IBM Z to store some of that information. So, for example, this MongoDB database stores the information about what flights are available from which cities to which destinations. So we have a couple different MongoDB databases, but we also have this Oracle database. This Oracle database is not running on OpenShift. Instead, it is running on native Linux, so Red Hat Enterprise Linux running on IBM LinuxONE. And this is holding all of the data and information about our customers. So, your name, your login information, maybe your credit card, and how many miles you have with the Acme Air company. So that's our sample application, and what we're looking at right now is the Instana dependency graph for our application perspective. So this provides an end-to-end view of all of the different individual services within our Acme Air application and how they pass data amongst themselves. So you can get a good visualization of how your microservices in OpenShift interact with one another, as well as with an external database, in this case, Oracle running on LinuxONE. If you look at the Instana summary dashboard for our application perspective, we can get all kinds of information about the calls, the call rates, any erroneous calls, latency, processing time, and infrastructure issues and changes. So one thing that's nice, if you start to see an issue, maybe you've got some type of error going on in this application, you'll be able to quickly do something like highlight on all charts, and then you'll be able to correlate that with maybe an infrastructure issue or change that occurred at the same time. So you can also break out that same page, that summary page, into each individual service. So maybe you're not interested in the entire Acme Air application as a whole. Maybe you'd like to just take a better look at this flight service. So we can now, narrowly scope to individual services that make up our Acme Air application, and you can look at their individual endpoints and the latency calls, all the same information, but now just scoped to our individual component. Any log messages and error messages will come up here as well, and you also have direct links to all the infrastructure components that make up this application. So Instana is great for applications, and I've got a lot of them defined here, but you can also take a look at some other types of technologies other than just your applications. Now we're looking at a website metric page, so you can take a look at your page views, any JavaScript errors, load times. You can also check out your speeds. You can filter by which type of browser was used, which operating system the request came from, and all types of different information, such as location from your requests and a bunch of other different things. So you can take a look at your applications, you can take a look at your websites, you can also take a look at some infrastructure components, including Kubernetes, or in our case, OpenShift. So this is our OpenShift cluster where our Acme Air pods are running. This is OpenShift on IBM Z. And you can take a look at your cluster level metrics for CPU, memory, number of pods, top nodes, and all the stuff that you're seeing on the page right now. You can also take a look at any of the tabs here. So for example, if I want to look only at my Acme Air project or my Acme Air namespace, you can now take a look at that individual page, as well as any deployments that are within this namespace, any specific pods, any services, and again, all of the tabs up at the top here. You can also take a look at Linux, so not just OpenShift, but Linux. In our case, this is our Linux, our RHEL virtual server running on IBM LinuxONE, and this is where our Oracle database is running. So you can take a look at any of the Linux metrics to see how your machine is running, and each individual host. So, for example, a Linux guest, or maybe a physical machine, or maybe a node in an OpenShift cluster. For each one of those individual hosts, you have a single agent running on that host. And each agent can then, in turn, have various sensors deployed from that one agent. So, for example, we have an Oracle DB sensor running on the host agent for this LNRG 4170 host, and that provides this direct link in this interface section to our Oracle database infrastructure. So if I click on that, I now can see all the information about my Oracle database that is running on my LinuxONE RHEL server. So if you are a DB admin, if you are responsible for your Oracle database, you have all types of information here that you can set up alerts for. You can forward this to a Grafana dashboard if you want to, and just in general, you can keep track of your Oracle database or multiple Oracle databases from this Instana perspective. And the last thing I want to show as I go through my tabs here in Instana is the IBM Z HMC capabilities. So I have a HMC called WSC HMC, and it has visibility into 3 separate IBM Z and LinuxONE machines. So you can see your machine type models, you can see your IP addresses of your machines, number of LPARs, and you can see that these machines are running in classic mode, but DPM mode is also supported. So let's take a look at one of my my Linux, or one of my IBM Z machines, and it's called FSys. This is the one that has 10 LPARs on it. So you also get the overhead view of your entire machine, CPU, processor usage, as a sum total. You can also break it down by individual processors. So we've got some IFLs that are doing some work here. And you also have this really nice environment and power dashboard. And this is really nice because a lot of customers that I talk to are interested in sustainability metrics. So I've seen customers using this power consumption panel here to keep track of how their IBM Z machine as a whole is doing for power consumption, and how certain application changes, or migrating applications, or from one Linux guest to another, or one LPAR to another, and changing weighting and all that type of stuff can have an effect on your power consumption, which in turn is responsible for the amount of carbon emissions that your IBM Z machine is responsible for. So I've seen a lot of customers using this for sustainability initiatives. So that's all I want to show from the Instana perspective. Let's go back to our Acme Air application. And right now you can see that this all looks good. It all looks healthy. We don't have a lot of erroneous calls. Sometimes just one happens for some reason or another. But in general, this is what we want to see. But let's change that. Let's introduce an error, and we'll start to use Instana to diagnose that error, and then we will move on to IBM Cloudpak for AIOps, which is my next tab up here, and we'll use that to actually remediate our issue. So I have a handy script here. And this script, it will essentially log me into my OpenShift cluster, set some variables, and then I will simply just close the port. So port 1521 is that's where Oracle is listening. So whenever I close that port and I restart my firewall, and I restart my customer service pod, this customer service pod will no longer be able to reach the Oracle database where all the information for the customer resides. So whenever I'm driving workload to this Acme application as a whole, whatever calls that end up hitting this Oracle database will no longer be successful. And so we'll start to see some error rates, and we can start to diagnose our problem with Instana. So let's introduce this issue. And you also notice I have this API call here, and I'll talk about that in just a minute. So let's launch this. I'll say that yes, I'm the correct person to run this script. You can see my port was removed from our allow list here in the firewall. The firewall was reloaded, and now I'm generating a new customer service pod. This customer service pod is what ends up calling Oracle, so I need to break that connection and start a new pod. So it should be up and running, and very shortly here we should start to see some errors in Instana. So let's zoom in maybe to the last 5 minutes, go back to our live environment here. And so the first thing I want to show you is this little release indicator with the text that says port 1521 removed from firewall allow list on that server, which is where Oracle is running. So this release indicator is coming from this REST API call that I ran as part of my script. So this is essentially an indicator that I made a change to my application, I made a change to my infrastructure, and you can put that API call anywhere. You can put it in your CI/CD pipelines. You can put it in your infrastructure as a service pipelines. Integrate it with your Git distribution if you're doing GitOps type of operations, I guess. And that essentially tells you when things change, so that if I start to see errors, like I should now, I can be pretty confident that this release had something to do with it. So whenever you push a code change to an application, or maybe you're changing your infrastructure configurations in GitHub, for example, you'll be able to see maybe what was the problem here. This port 1521 removed from firewall allow list, that's pretty direct for me to put in here, but you could instead substitute that text with something like your Git commit message, so that you could actually start to track back and find which exact commit started causing these errors. In any case, we have some errors. I'm going to pause this so they don't disappear from my screen. Let's just go to the last maybe 10 minutes, and actually let's go back to the last 5 minutes and keep it paused, or keep it running, I guess. So we've got some errors. We no longer only have 200 status calls. We also have some 400 and 500 status calls. Those are erroneous calls. Obviously, our erroneous call rate has increased, and you can start to diagnose what's going on here. So let's see the erroneous call rate. We've got 100% erroneous calls with our JDBC connection. I know that JDBC connection is how the customer service pod connects into Oracle. So you also see the customer service pod now has a higher rate of erroneous calls. And you can also see I've got these issues that popped up for my Acme Air application perspective. One is called sudden increase in the number of erroneous calls. Instana noticed that the rate of change of the erroneous calls was above the threshold that it is comfortable with. It has a high confidence in that being a problem. We also have this incident that is called too many status calls with HTTP status code 500. So, we have a threshold set here to 10%, where if we hit, 10% or higher error rate, we will we will trigger this rule. And we also just got a third one, set an increase in the latency for a fraction of requests. So our latency is also spiking. So we've got erroneous calls going up, our latency is spiking, our processing time is also spiking, and things are just generally not doing well right now. On our dependency graph, you can also see highlighted icons for the microservices that are now the highest call rate or highest erroneous call rate. We could also look at our services breakout page here and see that, again, our JDBC call is at pretty high error rate, 100%, and our customer service is also having some errors. So we have a pretty good sense of where where those erroneous calls are coming from now. If I pop over to my Oracle database, over the last 10 minutes, let's see how our Oracle database is doing. We can start to identify some changes happening here as well. So we've seen some spikes. We've seen a total drop in our number of logical reads. Our sessions are dropping. So we know it's got something to do with Oracle as well. We can also take a look at from our application perspective here. We could look at, this is kind of an overview of all of our calls, and there's quite a lot of them. We've got about 10 calls per second happening right now, even though a bunch of those are erroneous. But if I look at the past 24 hours, we've got about 1.5 million total calls happening over this time span, and we can look at every single one of those if we want to. So I'll hit this Analyze Calls button to take you to the Instana analytics page. Again, over the last 24 hours, let's actually zoom into the last 10 minutes here while we have our error. And Instana does not sample at all. So you're getting every single call, and it also has full traces. There's no partial traces of any of these calls. So let's find our customer service. And you can see that we've got a whole bunch of, indicated by the red. That indicator means it contains errors. So it looks like all of our post customer internal validate ID calls are erroneous. We can look at one individual call out of that 1.5 million over the past 24 hours. Then you get a visualization of the stack trace, your timeline, the calls and subcalls, and how things actually are going for this specific call. We can see an error code here, 500 internal server error. We get an error message, and again, this can all be used to diagnose our incident. Finally, we have these events occurring, and you can see how many events, how that changes over time. We can see that we've got a critical incident, that is our too many calls with HTTP status code 500. We also have our two warning incidents that we looked at earlier from our application perspective. So these are these are the incidents that we actually need to take a look at. So I've got a pretty good sense of what's going wrong. I know it's got something to do with my JDBC call being made over to Oracle. Now, we're going to send these events, these incidents and issues, over to Cloud Pak for AIOps, and we're going to let Cloud Pak for AIOps help us to solve our problem. So I just hopped over to Cloud Pak for AIOps. I'll give my page a refresh just to make sure it's up to date. And we can see that we're using that Instana server as a data or tool connection to send those alerts into Cloud Pak for AIOps. Let's just look at our data and tool connections here for Cloud Pak for AIOps. And I just want to show you that Instana is providing events, metrics, and topology to our Cloud Pak for AIOps. So that is where our data is coming from, and the data that we're sending here, along with our elk stack for logs, that data is being run through the AI models that are built and deployed and trained within Cloud Pak for AIOps. So we have some log anomaly detection being done. We've got a new model here that I trained just yesterday. We have metric anomaly detection, so any changes in metrics that are outside of the normal course of action. Those anomalous metrics will also trigger alerts in Cloud Pak for AIOps, and you can see all the different algorithms that are both trainable and pre-trained by IBM. So we've got a couple of them set up. So I said all the incidents and issues from Instana are coming into Cloud Pak for AIOps as alerts. Let's see what those look like when it loads up here. You can see we've got a lot of them. So the nice way to look at this, or the first thing to look at, is where the sender is coming from. So some of our senders are, that's coming from Instana. But we also have a log anomaly here. So the sender is actually coming. The sender for this alert is our log anomaly AI algorithm. And then similarly for our metric anomaly detection, this is basically telling us that there's something out of the ordinary. We know what the metrics typically are, and here's the metrics now. Something's different, and it's an anomalous event happening right now. So same with the log anomalies. If I go down here, I can see information about our log anomalies and which application is it's related to. You can also see it's maybe related to. It's not related to that one, I guess. It's related to this user group, and we can start to just dig into that log anomaly information as well. But the issue that we're causing right now is right here at the top, and it's actually a group of 10 alerts. So these alerts were grouped together because, again, another one of those AI algorithms in Cloud Pak for AIOps associated these all with one another. So we've got from both the Instana sender and our log anomaly AI algorithm, all these alerts. So we don't, this is just to reduce our noise a little bit. We don't need to look at each one of these individually. We might to diagnose this problem, but as a starting point, we know that they're all really related to one another, and the probable cause of the group of these alerts, it's all related. So we can just kind of look at these as a whole. But even with this grouping, I think this is still, too many alerts to start to we don't need to look through each one of these individually. So what we've done is we've set up a policy for if certain conditions are met, these alerts will be promoted to incidents. So you can see that our Acme error, too many calls with HTTP status code 500. That alert was promoted to an incident, and that's actually what we need to focus on. This is where we need to work. This is the actionable items that we need to fix this problem. So for this incident, we get the grouping of probable cause alerts. These are the alerts that are in a ranked order to be the most likely probable causes. If we want to look at all the alerts that are associated with this incident, we can do so, and you can see that each one of them has a ranking. And this is the same group that we just saw in the alerts page previously. You also get a topology. So this is pretty much like a blast radius of all the components that are affected by this incident. And you can see that it's all these Acme Java processes, these endpoints, this post internal validate ID, that's the endpoint that we saw was having issues earlier, as well as our JDBC call and the connect statement, that's what's supposed to be made over to Oracle. So you can get a topology view, and these topologies are actually coming from Instana as well, because remember, Instana is providing topology information as well as the metrics and the events. Back on our homepage here for our incident, we have some more information about what policy was used to trigger this incident, who's responsible for this. So this group of admins was tagged as being the responsible group, with specifically me being the owner. So I am responsible for working on this incident. We get the impacted applications, and if there were any related incidents, they would populate here. So the last thing that we get is a runbook for the other alerts. So some of the alerts, if I look here again in my alert page, have runbooks associated with them. So if I scroll to the right, you can see under my runbooks tab here, these two have runbooks associated with them. So they're both the Acme too many calls with HTTP status code 500. So for those alerts which were not ranked in my top 3 probable causes. So if they were, we would see the runbook for my selected alert up here if I was able to select it. But it's an other alert. It's also associated with this event or this incident, but it wasn't. It's not in my top three, so I can't select it over here. Either way, what this means is we've had this issue in the past. We've seen this incident. We figured out a fix for it, and we created a runbook to fix that problem more rapidly the next time it occurred. And now it has occurred, and we can be pretty comfortable that we can run this runbook to solve our problem. So it's ready to run. Our success rate is 100% in the previous iterations of this incident, and the average rating was 5 stars. So I feel pretty comfortable running this runbook to solve this problem. And you can see that it is the type is manual. So this means that somebody like me has to come in here and hit the run button to kick off this remediation activity. If you wanted to, you could set this as a automated response so that whenever this incident pops up again, it would automatically kick off this runbook for me. That is just not great for a demonstration. So I'm just gonna hit the preview button actually, and we'll see what happens. So this is a preview of our runbook. You can see that it's got 3 steps in it. 2 of them are automated, and one of them, the step 3, is a manual step, just telling us to go check on the application perspective to make sure that things are back to normal. But our automated steps here are 2 bash scripts that are made through an SSH connection to our Oracle RHEL server running on IBM LinuxONE, and it's going to run these 2 scripts. So let's see, the first script here, you can see the exact bash commands that'll be run, and it has these values for the parameters. So for example, if you need to use a parameter here for a different application perspective, that could be entered here. So this is the script that's going to run, and we get a little bit more of information about it. And we could do the same thing for the second one if we wanted to. So you don't have to use bash commands or bash shells or bash scripts via an SSH connection as your runbook steps. You could also use Ansible playbooks. You could integrate Ansible Automation Platform or Ansible Tower, or you can just use REST API calls. If you have something else that does remediation activities for you that's triggered from a REST API call, you could use that as one of the steps here as well. So we're just using bash, but there are other options. Let's hit run runbook. You could enter in, I use these as the default parameters, but you could change them if you needed it to run by a different user or a different application perspective in Instana or a different Oracle server, for example. You could either manually change these now, or you could pull this information from the metadata of the alert that triggered the incident that this runbook is going to remediate. So you could programmatically have this run against a different Oracle server if the issue was happening somewhere else, for example. So let's hit start runbook. Let's run our step 1, and this is our first bash script that we looked at earlier. It's in progress, and it's going to add the port 1521 back to my firewall allowed ports. So basically the reverse of what I did to cause this problem. You can see that it added the port, it reloaded my firewall, and then it put another release token over on my Instana application perspective. We'll look at that just in a second here. But it was successful, ran in 4 seconds. We'll hit next step. The next step is now really just double check that port exists in our firewall allow list. Just to make sure that everything ran smoothly in step 1. So let's just run this. Again, this is running a separate bash script on my Oracle server, and it's just checking the allowed ports, and it has determined that port 1521 is in fact allowed. That's great. Let's go to the next step. Step 3, now nothing is going to be automatically run. There's no scripts here. There's no Ansible playbooks here. This is simply just telling us, hey, go in, check the Acme application perspective on Instana to make sure that the erroneous calls are dropped back down to 0, and that your application is performing like it typically does. So we get a direct link here, and it'll take us to our application perspective in Instana. And if I maybe zoom into the last 5 minutes, we can get a better look at our 200 status calls have taken over again. We no longer have any erroneous calls, either 400 or 500 erroneous calls. Our latency is back down to below 100 milliseconds where we want it to be, and our processing time is also back down. You can also see we got another indicator here that port 1521 was added to our firewall allow list, so we know what the solution was that ended up reducing our error calls back down to 0 or negligible at least. So we get a little indicator of that being the fix. So these issues will drop off after Instana has determined that they're no longer an issue. It just takes a couple minutes for Instana to determine that the problem is actually gone and not just temporarily removed. But in any case, everything looks good to me. It looks like the runbook ran well and did what we wanted it to do. So I'll hit complete for my step 3. Let's give it a 5-star rating, and we'll say that runbook worked, so that the next time this occurs, somebody can use that runbook again. So let's go into my incident settings. We'll change the status to resolved so that anybody who is working on this incident can no longer, or doesn't need to focus on it anymore. They know that it's fixed, and they can go in to look at the next incident where they can start to focus their time again. So everything, that's pretty much the end of the demonstration that I wanted to show. There's a lot of capabilities that Instana and Cloud Pak for AIOps have that were not covered in this demonstration today. But the goal here was to use Instana and Cloud Pak for AIOps to diagnose and remediate incidents in your OpenShift and Linux on IBM Z or LinuxONE environments. And I thank you for watching.